Alright, ladies and gentlemen, it is time for solutions. Not solutions like the answers to a test or anything like that. Instead, solutions are something dissolved in something. And it can be a variety of things. It can be ions dissolved in water. It can be gas dissolved in a liquid. It can be a solid dissolved in a solid. So there's lots of different combinations you can have. Our main focus for this unit is going to be on the solids or ionic compounds dissolved in water. So solutions like that, they can be all different kinds of things, like Gatorade. Gatorade is different electrolytes dissolved in water. The ocean, that's different kinds of salts dissolved in water. Grape Kool-Aid, that's purple dissolved in water. So you can have different kinds of things dissolved in a liquid, and that's what makes a solution. So also dependent upon solutions is how much stuff you have dissolved. So how much purple did you dissolve in that water? If you put a little bit in, it might be slightly purple. Whereas if you put a lot in, it's going to be really purple. And that's what we call concentration. So the amount of stuff that we have dissolved does make a difference. You can't just say, oh, there's purple in water and that's a solution. You've got to specify how concentrated or dilute a solution is as well. So let's talk real quick about how solutions fit into the grand scheme of things. So you remember from the first time you stepped into science that everything is composed of matter. Everything's a matter. And matter can be broken apart then into different kinds of matter, essentially. So we can ask a couple questions with this little flow chart. So if it can be separated by physical means, that means that you can use things like a filter or a magnet or your hands to separate it out. If it can be separated like that, that means it's a mixture. If you can't separate it, that means it's a pure substance. Think of water. Water is H2O. If you've got a glass of water, can you separate those H's and those O's from each other with a filter, with your hands, or with a magnet? And the answer is no, you can't. That's what makes it a pure substance, and so it's either a compound or an element. In case of water, it's a compound. But if you can separate them by physical means, think of like sand that's in water. You can filter out that sand so it can be separated by physical mean. That means it's some form of mixture. So then, is the mixture a uniform composition? Can you see the individual pieces, or does it look the same? So think of like sand in water, versus purple Kool-Aid. If you look at the sand and water, if you kind of squint, you can see those individual sand particles, so you can see a distinction between the two things that are in there. Whereas if you squint really hard and look at your purple Kool-Aid, you're not going to see any difference between the purple and the water. It's going to look the same. It is a homogeneous mixture. Homo, meaning the same. Hetero, meaning different. And so a homogeneous mixture, that would be a solution. They're a type of homogeneous mixture where you can't see those different parts. So other things would be like air. If you think of air, there's a whole bunch of different gases, nitrogen, oxygen, argon, a little bit of helium and hydrogen mixed in there as well. That makes it a homogeneous mixture because you can't see those individual types of gases. Sugar and water, if you think of sugar dissolved in water, you can't see the sugar. Stainless steel, there's a solid and solid. That's iron and carbon. You can't see the iron versus the carbon. It just looks like one solid thing. So that's a homogeneous mixture, and that's what a solution is. Some definitions. So a solute and a solvent. These are the two things that make a solution. You can't have a solution without a solute and a solvent. A solute is what is being dissolved in the solution. A solvent is what does the dissolving. It's the dissolving medium. So the thing that dissolves is the solute. So a solvent dissolves a solute. A solute could be something like salt. Okay? And if we dissolve that salt in water, so if we want to make ourselves a glass of salt water before bed, we would dissolve some salt in water, and that would make water our solvent. And water, just so you know, that's going to be almost our universal solvent during this unit. Every single solution, almost every single solution that we talk about during this entire unit, water will be the solvent. Our solute changes, water, sodium nitrate, copper chloride. A lot of different elements, compounds can go into there. But our solvent is almost universally going to be water. Another way to think about the solvent is whatever there's more of. So if you think of when you're adding your purple to the Kool-Aid, so there's your pitcher, and you'll have water in there, and you'll probably have about half a gallon of water. And then when you add the purple flavor, you'll add like a scoop or two. And so that means there's going to be more solvent, your water, than there is solute, the purple. And so that's another way of recognizing solute versus solvent, is the solute is always the smaller one. So there's less solute than there is solvent. Okay, and just another thing about solutions real quick. So when we're dissolving solids in a solution, so typically water, a couple things that we can do to help them dissolve. So solids tend to dissolve best when they're heated, when they're stirred, and when they're ground into small particles. So if you think of dissolving some sugar in tea, hot tea will dissolve more sugar and it'll dissolve it faster than cold tea would. When you stir them, so you put that sugar in the tea, if you just let it sit there and try and sip it, all that sugar is going to fall straight to the bottom, and you're going to end up having a really sweet last dregs of tea. But if you take a spoon and you stir it up, that's going to help dissolve it inside the entire thing and spread it out. Also, grinding into particles. So if you think of a sugar cube versus grains of sugar, so granulated sugar, the cube is going to dissolve slower than the granulated sugar would because it's harder for it to kind of mix in with everything else. Gases, on the other hand, they dissolve better when it is cold. So what do you mean by gases in solutions, Mr. Jones? I've never heard of such a thing. You have. Every time that you drink a glass of pop, that is a solvent of some kind of liquid, typically water, with a bunch of things dissolved in it, but one of the things that's dissolved in it is CO2, carbon dioxide gas, and that's what makes the little bubbles when it touches your tongue or on the side of the glass. There is carbon dioxide, a gas, dissolved inside of that solution. So think of a glass of pop. What makes a pop go flat? When it gets warm, if you leave it sitting out on the counter and it gets warm, that's going to make it go flat because the gases don't dissolve as well, and so some of that gas is going to come out. Also, they dissolve better when the pressure is high. Think of a bottle of pop with waves in it. If you leave the lid off, that means the pressure is going to be really low, and so all that gas can escape. Whereas if you seal off that top, that means no gas can escape, and it's going to be high pressure in there pushing down. That's what keeps it dissolved. So solids dissolve best when they're heated, stirred, ground into particles. Gases dissolve best when it's cold and the pressure is high.